Hey everybody, welcome back to another edition of Notes. In this video, I'm going over section 7 of chapter 10 titled Special Segments in a Circle. So at the top of the notes here, I wrote when two chords intersect inside a circle, each chord is divided into two segments called chord segments. If two chords intersect inside a circle, then the products of the lengths of the chord segments are equal. So in example 1a, this picture right here, I have AB times BC. AB times BC will equal that of DB times BC. Okay? So we're going to do that to solve for x here. So I have x times 10 for EB and DB. So I can just write 10x for x times 10. And then I have 5 and 12 for my other two. So 5 times 12. I know that 5 times 12 is 60, so here I have 10x equal to 60, and so what is 60 divided by 10? And that is going to be 6, so x equals 6. For example, B here, I have 6 and 4, so I'm going to say 6 times 4 equals 3 times x, so 3x. 6 times 4 is 24. 24 equals 3x, so I know 24 divided by 3 is going to be 8, so I get x equals 8. This last one, you have 3x and x, so 3x times x equals 8 times 6. So 3x times x is actually 3x squared, and 8 times 6 is 48. And so what you'll want to do is you'll want to divide both sides by 3. And 48 divided by 3 is 16. So you have x squared equals 16. And so how do you get rid of a square? You square root it. So the square root of 16 is going to be 4. So x equals 4. And so if I ever ask you to plug it back in, you'd say, hey, well, this is 4, and this is 3 times 4. And 3 times 4 is, of course, 12. Next, I wrote a secant segment is a segment of a secant line that has exactly one endpoint on the circle. In the figure, segment AC, AB, AE, and AD are secant segments. So we're looking at this figure right there. A secant segment that lies in the exterior of the circle is called an external secant segment. In the figure, segment AB and segment AD are external secant segments, so these little parts right here. A special relationship exists among the secants and external secant segments. So here it says if two secants intersect in the exterior of a circle, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. Okay, so what does that mean? It says AC times AB equals AE times AD. So you have AC, the whole length of it, times AB, the outer external segment, right? And then that's going to equal the whole length of the other segment, AE, times AD. So when I'm given a picture like this, you'll want to define the length of your secants. So 10 plus 6, that one's 16. And then x plus 8, that can't really simplify. So you're just going to have to write it as x plus 8. So what we're going to do is we're going to set it up just like it did here in this example. We're going to do the total length times the outer one equals the other total length times the other outer one. Okay, so using the external segment 8 times the total segment x plus 8, that's going to equal 6 times the total of 16. So we'll distribute everything. 8 times x plus 8 turns into 8x plus 64. 6 times 16 turns into 96. So let's minus that 64 to the other side. And 96 minus 64 is going to give me 32. And so I'll bring down that 8x. And so I'll divide both sides by 8. And 32 divided by 8 is 4. So with x being 4, then you can say that, hey, if I ask how long like GJ is, you would just say it's 12 because 4 plus 8 is 12. So let's do another example like that. Here I have 4 and 8, so 4 plus 8 is going to be 12. And then here I have 3 and x, so you're just going to write 3 plus x. Okay, so here I have it set up. 4 times 12 equals 3 times 3 plus x. So let's multiply, aka distribute. So 4 times 12 is 48. 3 times 3 plus x will make 9 plus 3x. So that means I'm going to have to minus 9 to the other side. And 48 minus 9 is going to be 39. And 39 equals 3x now. So divide both sides by 3. And 39 divided by 3 is going to give me 13. So, again, if I ever ask you to plug it back in, you could tell me that this is 13, and so AE would equal 3 plus 13, which is 16. Okay, my next couple of examples will be just like that. I'm going to find the value of x, and then I'm going to plug it back in to find the measures of my secants. Okay, so looking at this picture, I have x minus 3 on the inside and 4 on the outside. So combine those for your total. Negative 3 plus 4 would give you a positive 1. So the total length is x plus 1. And then same thing on this. This is x minus 6 on the inside and 5 on the outside. So negative 6 plus 5 would make negative 1. So the total length of the segment would be x minus 1. So set this up like we did with the others. Take the outside, the external segment, and then multiply it by the total length. And so I have 4 times x plus 1 equals 5 times x minus 1. Let's go ahead and distribute and solve for x. So 4 times x plus 1 is 4x plus 4. 5 times x minus 1 is 5x minus 5. So I see that 4x is smaller than 5x, so I'm going to want to minus my 4x over to the right-hand side of the equation. And so 5x minus 4x is just x. And then I'm going to want to add my 5 to the left-hand side of the equation now to get all my constants on one side. And 4 plus 5 is going to give me 9. And so I just have 9 equals x. So if I were to plug 9 back in for this internal segment, 9 minus 3 would give me 6. The total length then would be 10, doing 9 plus 1. Makes sense, right? What's 6 plus 4? And then the other one, 9 minus 6 would give me 3. And then the external one would be 9 minus 1, which is 8. And that's the same thing as doing, since you know that this one's 3, 3 plus 5 also equals 8. Okay, so example B here, I have 4 and 2, so that's going to make this 6. And then I have 3 and 2x plus 5, so add your like terms, this is going to be 2x plus 8. Okay, so setting it up, I'm going to have 4 times 6 equal to 3 times 2x plus 8. 4 times 6 is 24, and 3 times 2x is 6x, and 3 times 8 is 24. So since we have 24s on both sides, they're actually going to cancel. And if that confuses you, just think, if I were to minus 24 to the left-hand side or minus 24 over to the right-hand side, they would both equal 0, right? So what we have here is something that says 0 equals 6x. So if 0 equals 6x, then x must equal 0. So if x equals 0, then plugging it back in, LK would be 5, because 2 times 0 is 0, plus 5 is 5. And so the total length of MK would be 3 plus 5, and that's just 8. The last thing on this note looks very similar, but it is actually a tangent segment. And so the secant segment is both of the lines go through the circle, and then a tangent segment is only one of the lines goes through the circle and the other just meets the edge of the circle. So this is a tangent segment right there. And so what you're going to do is you're just going to square the value of this measurement, and then that's going to equal this short piece, the short external, times the total one, like you did on the other formula. So in example 4a, it says segment PQ is tangent to the circle, find x, round to the nearest thousandths place. So let's see here. We have 5 and x is on the inside, so that means the whole length of SU is just going to be 5 plus x, or x plus 5, doesn't really matter. And then SR, you're going to square that. So we're going to get 9 squared equals 5 times 5 plus x. And so 9 squared is just 81. 5 times 5 is 25. And 5 times x is 5x. And so we're just going to minus 25 to the other side and then divide by 5. So we get 81 minus 25, and that's 56. 56 divided by 5 is exactly 11.2. So I didn't need to do any rounding on that one at all, actually. So I'll do 2 more examples very similar. I'll find the value of x, and then I'll just plug it back in to find the measure of the secant, or in this case, this one's the tangent line segment. Okay, so for this setup, it was simple. Just do x squared equals, and then get the total amount. That's 12, 9 plus 3, times 3. And so 12 times 3, 3 times 12, it's 36. And so you have x squared equals 36, so you got to go backwards. That means take the square root, and the square root of 36 is 6. So this side is 6. In part C, I have another similar example. My tangent segment is 15, so it's going to say 15 squared equals, and then my secant segment, the total length of it, would be 3x plus 4 plus 9. So 4 plus 9 is 13, so I have 3x plus 13 here. And so I'm going to do 3x plus 13 times 9. And so you got to distribute. What's 9 times 3x and what's 9 times 13? 9 times 3x is 27. 9 times 13 is 117. And 15 squared is 225. So next I'll want to subtract 117 to the other side. And 225 minus 117 is 108. So I have 108 equals 27x. And so I'm going to divide both sides by 27. And so 27 times 4 is 108, so x equals 4. And now let's just plug it back in to figure out the length of the secant segment. So we have 3 times 4 plus 4. So 3 times 4 is 12. 12 plus 4 is 16. And then if we want the whole thing, we just add 9 to it. That's 25. Or you could also just say, plug it into the 3x plus 13, which is what I'll do right now. So I'll say 3 times 4, 12, plus 13 is 25. So that's the length of my missing segments there. So that's going to wrap it up for the notes. Thank you for watching. Hope you learned something, and goodbye.